Einstein's general relativity works perfectly well in predicting and describing gravitational phenomena by treating it as due to the curvature of space-time. Yet, quantum physics, or quantum mechanics, insist on treating it as a force without even trying to refute Einstein's geometric theory. It's puzzling, to put it nicely. The only reason I can see is that quantum theorists simply want to take over all of physics. I'm going to show here, without need of any mathematics, that gravitation is not a force, and hopefully relieve quantum theorists of the need to include gravitation in their search for a unified field of force theory. Just one principle is needed for anyone to follow along here in this brief presentation. A geodesic describes the path a body follows when moving freely in space-time. In a gravitational field, a geodesic path may curve toward a center of gravity, as when a spacecraft orbits the Earth. When in a free fall in a gravitational field, as are the mathematician and the giant sphere shown here, bodies follow their geodesics directly toward the center of the mass that generates the field. Note that the large hollow sphere is rigid but hollow, so it has very little mass. You'll see why that's important as we continue. A little later, the geodesics of the two bodies can be seen converging as they free fall toward the center of the Earth's mass. There is, as yet, no evidence of a force being involved. Incidentally, it is often said that there is no difference between being accelerated in a rocket out in space and just standing on the Earth's surface, but that is incorrect. As the paths of the mathematician and the sphere indicate, there will be a convergence, however slight, between two bodies falling or standing in a gravitational field. If a person drops a ball in an elevator on Earth, the ball will fall slightly toward her. As the two bodies continue to fall, the mathematician's free fall is interrupted when his geodesic comes in conflict with that of the sphere, and he is actually able to stand on it, but not because of the sphere's gravity. It is hollow, and its mass is negligible. The sphere is thus preventing the person's geodesic from continuing a free fall toward the Earth's center of gravity. It is, in effect, pushing him out of his geodesic. I've used this contrivance of a conflict of geodesics between a falling body and a large hollow sphere to show that the idea of gravity as a force is mistaken. It demonstrates that it is only when the person and the sphere collide with the Earth's surface that there is a direct incidence of force, and that's where the surface and everything below are already pressing toward the Earth's center of gravity, and they naturally resist the new intrusion. So it is not gravity, it is a resistance to gravity that introduces a force on the late mathematician and the crushed sphere. But wait, this doesn't explain how a purely geometric phenomenon, the interaction of the falling bodies and then their intersection with the third body, the Earth, will continue to press against the surface. What can be compelling them to continue? There must be a force of some kind, not of geometry, which is not intrinsically dynamic. So what then can it be? Well, that, as they say, is a whole nother story. If you're interested in pursuing it, I invite you to visit my paper at the link below. And thank you for watching and listening.